Good afternoon, children. Today we are doing an exercise from our practical syllabus to find the strength of an unknown solution with the help of a known solution, and this process is called titration. Here we are doing acid-base titration. Titration can be done by redox reaction also between oxidizing and reducing agents. Here we have to do acid-base titration. So your aim is to find the molarity of the unknown solution and the strength of that unknown solution. You are provided with two solutions. C10 is a solution of potassium hydroxide, which is a base containing 3.5 grams potassium hydroxide per liter, and C11 is a solution of sulfuric acid, and we don't know the strength of this sulfuric acid. With the help of this process of titration, we can find the concentration of the C11 solution. Basic principle used here is neutralization. So acid reacts with a base to form salt and water, and this process is called neutralization. How we will come to know that the process of neutralization is done or acid has been completely neutralized with base? For that we will use an indicator, and here we are going to use methyl orange. You know, methyl orange turns pink in acidic medium, and in basic medium it remains either orange or turns yellow. So for this process, the apparatus which are required, this is burette and this is pipette. One solution we will fill in burette, and another solution with the help of this pipette we will take in a conical flask. So here I have taken sulfuric acid in burette. We have to calculate the molarity of C10 solution, molarity of C11 solution. C10 solution is KOH, and we know the mass of it. So its molarity can be calculated directly by putting it in the formula. You know what is molarity? Molarity is number of moles per liter of solution, and moles can be calculated by given mass upon molecular mass. So given mass is 3.5 and molecular mass is 56. So per liter, here in the formula we have 1000. This 1000 is used just to convert it into liters, because generally it is given in milliliter, but here it is given in liter only. So here volume also I am taking in liter. So 1 liter is equal to 1000 milliliter. So with the help of this formula we can calculate the molarity of it. So this molarity is calculated directly because its mass is given. But to calculate the molarity of sulfuric acid, we will use the formula M1V1 is equal to M2V2, where M1V1 is for acid and M2V2 is for base. M2 we have calculated here. V2 we will take here when we will do the process of titration. We take a fixed volume of that base, so that we will put here. V1 will be the volume that we will get with the help of this burette, and after putting these values we can get the molarity of the solution. Here one more thing is there. 1 mole of sulfuric acid is getting neutralized with 2 moles of KOH. It means M1V1 upon M2V2. They are reacting in a ratio of 1:2, because M1V1 is for acid, M2V2 is for base, and their ratio is 1:2. Because 1 mole of sulfuric acid is neutralizing 2 moles of potassium hydroxide. So that's why we use 1/2 here. So with the help of this formula we can calculate M1, which is the molarity of given acid. Then once the molarity of the acid is calculated, then we calculate its concentration, because concentration or strength, it's the same thing. Here it is written concentration of C11 solution or strength of C11 solution. For that we use the formula molarity into molecular mass. Molarity you will get with the help of this step, and molecular mass of sulfuric acid is 98, and its unit will be grams per liter, because strength or concentration is expressed in terms of grams per liter. Now let us see how do we go for this process. First, fill your burette, put this funnel here, and with the help of funnel we put the acid solution in burette. So C11 I have taken in this burette and remove the funnel. I have already filled it with C11 solution. When you fill it, you have to keep one thing in mind. If we are using upper meniscus here, we will use upper meniscus for pipette also, and if you are using lower meniscus, use lower meniscus in pipette also. Lower or upper meniscus means, suppose this is the mark, here it is written, the marking is done here, it is 0 at the top and 50 at the bottom, its volume is 50 milliliter. So this is the marking, and if we use the meniscus in this way, just above the mark, it is called upper meniscus. We can use lower meniscus also in this way. So whichever you are using in burette, the same you have to use in pipette also. So this burette is filled with sulfuric acid. Now we will take 25 ml of KOH solution with the help of a pipette in a conical flask. I have used upper meniscus in burette, so I will use upper meniscus in pipette also. So transfer 25 ml of potassium hydroxide with the help of a pipette in a conical flask. Put 2 drops of indicator into it, and our indicator is methyl orange. It will show no change right now because potassium hydroxide is a base, and base does not give any color with methyl orange. Now we will add this solution which we have taken in burette, that is acid, drop wise, and we continue this process with constant stirring till with 1 drop of acid we get a pink color here. So this process is done very slowly because we have to find that last drop which will convert potassium hydroxide solution pink, because that time the process of neutralization will take place. All KOH will get neutralized and 1 drop of acid will give pink color with the indicator. This value which we will get on burette, it is called the reading of sulfuric acid which is required to neutralize a known volume of a base. Now this is the color is turned pink, and with the help of this reading we will find the volume which was used for the process of neutralization. And it is coming 26.2. This 26.2 is the volume of acid which is used. So we will fill it here in this formula. In the same way, we take this reading again and again till we get a constant reading. Like here we have got 26.2. So we should get 26.2 again and again, and that reading is called titer value. So we have to get titer value by repeating this process, and that titer value we will put here. Molarity we have to calculate. This volume we are getting with the help of this reading. M2 is the molarity of KOH which we have already calculated here, and V2 is the fixed volume of KOH, that is 25 ml we took. So that we will put here. So with the help of this we can calculate the molarity of acid. And once you calculate the molarity here, you can calculate its concentration in grams per liter, because strength is equal to molarity into molecular mass. Molarity you will calculate with the help of this step, and molecular mass is 98. You get the strength in grams per liter.